So I was in a meeting with a group of AP macro teachers a few years back, and we do that, your teachers get together, we talk about this stuff, and we're talking about approaches to the course. And a colleague of mine who's been doing this quite a while knows a lot about the subject, about the course itself. We're talking about the curriculum. And she says, ultimately what we want our students to understand concepts, every concept, if at all possible, in words, numbers, and pictures. And I thought that was brilliant. I really did. And I've held on to that and I've tried to use it. And that's what we're going to do today. We're going to look at that philosophy, that approach to AP macroeconomics. Can you look at multiple concepts and understand and communicate them in words, numbers, and pictures? Meaning, can you verbalize, describe each concept? Can you understand them quantitatively? Can you work through calculations? Can you interpret data to say the same thing as the numbers? And can you express them in pictures? Can you draw the graphs? Can you show what it is that you know about this? We're not going to go into great depth in terms of specific concepts. We're going to use concepts to show these connections, these parallels between words, numbers, and pictures. So that's what we're going to do today. Let me share my screen here and get things started off on an official capacity. As once again, my name is Matt Romano, and I'm coming to you from Atlanta, Georgia at Marist School. And as I said, today, what we're going to do, what we're going to learn is how we can communicate, how we can express various concepts in three different ways. And the concepts we're going to focus on are output gaps, fiscal policy, and international trade. It's not to say those are the only ones, but they're so obvious and they're so applicable in terms of expressing them three different ways that I thought it would be a good place to start and a good place to start the conversation in terms of how we do this. And what I hope you get from this really are the skills, how we make these connections between the verbal expression, the graphical expression, the numeric expression of these three different concepts. And even furthermore, and I'm sure I'll say this again, how we can take that with us long after AP Macro, the class, is over. When you're out there in the world and you're watching the news and you hear things expressed in ways that you haven't thought of before, how do you make a connection back to what you learned back in that good old AP Macro class you took in high school? That's really the goal. And that's what my friend's conversation was about as well. How do we make those connections? How do we understand how to activate knowledge when it's out there in the real world, sometimes expressed in ways that we haven't seen before? So the ability to express these concepts verbally, numerically, graphically is going to help you, on the AP exam, of course it will, but it's also going to help you out there in the world. And that's ultimately the goal here. So let's go there. To start off, we're just going to warm up a little bit, just a little refresher about what we're talking about here, in particular with regards to those three concepts that we're going to do. I chose them again because starting at Unit 3, really these concepts span the entire AP Macro curriculum. Units 1 and 2, they're just getting our feet on the ground. We're just starting to understand what macroeconomics is and how it works. But from Unit 3 on, we're really doing macroeconomic analysis. So we're looking at output gaps. We're looking at that difference between actual and potential GDP. We're going to look at fiscal policy, stabilization policy, one option for what governments can do if they look to stabilize the economy. And then we're going to look at international trade and theories of international trade and work our way through some opportunity cost related comparative advantage type questions. And again, see how they are expressed in different ways. Ultimately, again, the theme today is how can each of these three concepts be expressed three different ways: words, numbers, and pictures. So have that in mind and let's get going. First things first, let's look at an example of output gaps. We want to express output gaps three different ways. In words, it's quite simple. We're going to describe a deviation between real GDP and full employment output. Now, embedded in that is an understanding of those terms: real GDP, actual real GDP, and full employment output. So we'll go there in just a moment. In numbers, we need to be able to calculate that gap. We need to be able to look at actual data and calculate the output gap itself, or in some cases, simply interpret data that tells us that an output gap exists. And you'll see what I mean about that in just a moment. And then finally, in pictures, we should be able to illustrate output gaps on numerous graphs. ADAS comes to mind first. I'm sure it's not the only one. We're going to show three different ways we can do it, and there are others out there that we could use to illustrate what an output gap looks like. So have that in mind. So again, same concept, 3 different ways to express it. All right, let's start with the words. Again, the simplest way to define is that we have a deviation between actual GDP and full employment output. Actual real GDP, of course, representing the actual output, the actual level of production for a given economy at a given time, as opposed to or compared to that full employment output. Let's, again, remind ourselves what we're talking about here, because there's always going to be more than one term to express something. That full employment output would be the output produced when utilizing all resources to their full productive capacity, their efficient productive capacity, sometimes also referred to as potential GDP or potential output. These are all synonymous terms. In the long run, we assume that actual output is going to equal full employment output, but we know that in the short run, gaps are going to exist. How do we define those gaps? Well, here's a reminder for you. We have 2 types of output gaps. We have recessionary gaps. Recessionary gaps exist when output is below full employment, when the actual output being produced is below full employment. That means we have some idle resources. Typically, it's going to mean that we have an elevated unemployment rate as compared to the natural rate of unemployment. We can also have inflationary gaps, an output gap that exists when we're actually producing output, when an economy is actually producing output that's beyond full employment, beyond that productive, efficient level of output that we are predicting for any given economy. Okay, that's the briefest and most simple way to define what output gaps are verbally. Can we do the same thing numerically and graphically? Of course we can. Let's make those connections here. By the numbers. The most obvious way that we're going to do this, and we'll do this quite often, is comparing actual to potential output. Here's an example, hypothetically. Let's assume that full employment output equals $10 trillion, yet we're currently producing $8 trillion worth of goods. Can we calculate an output gap from this data? So we have a full employment output level of 10 trillion. We have a current or actual output level of 8 trillion. The way we would interpret this is to say, because our current output is less than full employment, a recessionary gap of $2 trillion exists. We are saying the same thing here in numbers with data that we said with the words in our initial expression. This isn't the only way we can do this, though. This isn't the only number we can use. This is the most direct. This is the most obvious because we're actually looking at the output gap, the difference in output. But there are other numbers, other indicators that can also tell us the same story, and we need to be aware of that. For example, unemployment. When we look at the actual unemployment rate, the actual data calculated, and compare that to the natural rate of unemployment, we can also see the existence or the presence of an output gap. So once again, let's remind ourselves what we're talking about here. The actual unemployment rate, well, that's the number of people unemployed as a percentage of the labor force. Whereas the natural rate of unemployment would just include the structural and frictional unemployment as a percentage of the labor force. That's the unemployment rate we assume when we're at full employment output. Very important, again, to make those connections. And that's what this video is about. It's not an overly technical video. It's about making those connections between concepts, between different terminologies, and understanding that with different words, we're saying the same thing. So here, comparing actual to the natural rate. So let's assume that we have a natural rate of unemployment of 5%, and we have an actual unemployment rate of 7%. What can we conclude from that? So the natural rate of unemployment, NRU, is 5%. The actual unemployment rate is 7%. Because the unemployment rate is greater than the natural rate, we know that some cyclical unemployment exists, and that tells us that we have a recessionary gap. There is the presence of a recessionary gap in this particular scenario. So again, communicating output gaps in more than one way. We're not specifically talking about output here. We're talking about unemployment, but it's that change or that difference in unemployment that results because of the output gap. So in this case of a recessionary gap, we're going to have some cyclical unemployment. The unemployment rate is going to be higher than the natural rate. Of course, if there was an inflationary gap, it'd be the opposite. We would have an unemployment rate which is less than the natural rate of unemployment. So that said, we've done the words, we've done the numbers. What comes next? The pictures. How do we show output gaps on our graphs? Well, like I said earlier, the most obvious way to do this is to show output gaps on ADAS. That's where we actually have output represented. So as you well know, here's an ADAS model. We have price level and real GDP, upward sloping SRAS, downward sloping aggregate demand, and we have an equilibrium, a short run equilibrium where those two curves intersect. The recessionary gap on ADAS is this gap right here, represented by the difference between our current output Y and our full employment output YF. That gap, that horizontal gap right there, is the recessionary gap. We can also conclude from that unemployment is elevated, unemployment is higher than the natural rate. Unemployment's not on this model. It's not literally explicitly on the model, but we can connect unemployment to what's happening down here on the x-axis. And if the full employment output level is greater than the actual output, we know there's cyclical unemployment. We know that unemployment is higher than the natural rate. All of that occurs with a recessionary gap. Where else, though, can we do this? What other graphs can we use to indicate that a recessionary gap exists? Well, first ask yourself, where else can we show output? And possibly the easiest and most obvious answer is, let's go back to Unit 1 and let's look at a PPC. A recessionary gap on the PPC, we should know and understand, exists when output, in this case, output level A, is operating below full employment. And we know that PPC, the curve itself, represents full employment output, the same thing that vertical long run aggregate supply curve represented. So any output level below the curve represents output below full employment, telling me that we have a recessionary gap. Our current output is less than full employment. Our unemployment rate is greater than the natural rate. Okay, well, there's two. I promised three. What's the third graph? What's another graph that can illustrate that a recessionary gap exists? Well, in this case, it's not going to show us output, but it's going to give us enough information to make a conclusion about output. And that would be on a Phillips curve. So now we've jumped from Unit 3 to Unit 1 back to Unit 5, and now we're talking Phillips curve. In this case, if you look closely at this Phillips curve, we don't have output, obviously, as I noted. Output's not listed on here. We have inflation versus unemployment. But when we show, as we've done right here, as we show an equilibrium inflation and unemployment, where unemployment is greater than the natural rate, then we are indicating that a recessionary gap exists, simply by the fact that unemployment is greater than the natural rate. And again, that corresponds to the data that we already talked about, that with an unemployment rate greater than the natural rate, cyclical unemployment exists. We have a recessionary gap. There are idle resources out there in the economy. This is the one that confuses a lot of students, because we try to make parallels between ADAS and the Phillips curve, and we have to be careful. We know that in the case of ADAS, as we showed just a moment ago, that recessionary gap exists to the left of the long run aggregate supply curve, that vertical line. So we get that in our heads. We've known that for a while by the time we get to the Phillips curve, and it's so easy to confuse that and think that the same thing is true here. It is not. Make that connection to the data, and this all becomes that much easier for you. A recessionary gap is represented here by by unemployment. I made the mistake myself, by unemployment levels which exceed the natural rate. That's your recessionary gap on the Phillips curve. Easy mistake to make. We've got to make sure we understand that's why it is. Okay, so it comes down to interpretation. How about inflationary gaps? Let's make sure we understand those, kind of run through those rather quickly. Output gaps on the graph, inflationary gap as represented by ADAS, our old favorite ADAS. Now we're operating with output levels beyond full employment. And at that point, with output beyond full employment, we should know unemployment is going to be less than the natural rate of unemployment. So an inflationary gap on ADAS is going to look like this. We're going to have our short run equilibrium to the right of LRAS, to the right of our full employment output level. Let's put all that to use. Let's practice it. Very brief, but still helpful, I hope. Simulated FRQs, okay? Just portions of FRQs. Let's walk through two different scenarios. Now, again, none of these by themselves would be an FRQ. Each of these would be parts of an FRQ. But again, it's good to practice the little pieces of FRQs so that when you come to them, you have experience, you have confidence, and you know how to apply the knowledge that you've built up over the course of this year. All right, so we have 2 different simulated FRQs, portions of FRQs. Let's walk through each, see how they go, and move on from there. So I'm going to put each one individually on the screen. You can go through and answer it, pause, answer it, and then we'll go over your responses. First one, simulating output gaps. Assume output in country X is currently below full employment. Draw a correctly labeled graph of aggregate demand, short-run aggregate supply, and long-run aggregate supply. Identify the short-run equilibrium price level and output, as well as full employment output. So this is very straightforward. This is just pure practice. This is almost like a warm-up at the start of class. Go ahead and pause the video, draw that graph, and we'll check our work, make sure it makes sense. Okay, I'm going to assume you drew the graph. Let's take a look. Start by simply drawing your short-run equilibrium. You've got your axes labeled correctly. Always label your axes correctly. You've got your upward sloping SRAS, downward sloping AD, and where they intersect is your current price level and output level. Now, how do we show that that is representative of a recessionary gap, that you are currently below full employment? All we have to do right now is add long-run aggregate supply. It's got to be to the right of our current output level, and in doing so, we have illustrated a recessionary gap. So yeah, that was simple. I know that's essentially a warm up, but it's a good way to warm up, especially before taking an exam, to make sure, again, you understand the concept and you're ready to go. All right, let's look at another. The data in the table below represents the employment situation in country Z. Calculate the unemployment rate and the natural rate of unemployment. Does the data indicate a recessionary or inflationary gap? Explain. Draw a correctly labeled graph of the short run and long run Phillips curve, identifying equilibrium consistent with the output gap. So again, pause the video, evaluate the data, work your way through it, draw your graph, turn the video back on, and we'll look at the correct answer. Okay, so what do we have here? We have employment data. You have employed full-time, employed part-time. You have all 3 types of unemployment. Then you're told who's not in the labor force or how many are not in the labor force. If I'm given this kind of data, this is just my own suggestion here, you do what works for you, but I'm going to process the data first. I'm going to put it into categories. How many people are employed? Well, 13,500. How many are unemployed? Total, 1,500. What is my labor force? Total, 15,000. I'm going to jot that down somewhere because I'm going to need that information, especially in this case, when I'm being asked to calculate a couple things. So have that information ready. Once you have it, it becomes a much easier question. You're asked to calculate the unemployment rate and the natural rate of unemployment. The unemployment rate, as you know, is going to be the number unemployed divided by the labor force. We have 1,500 unemployed. We have 15,000 in the labor force. 1,500 divided by 15,000 times 100. Don't forget that times 100. That gives you 10%. So our unemployment rate is 10%. Our natural rate of unemployment is only going to include the structural and frictionally unemployed workers. So we get rid of the cyclically unemployed. It's the 700 and the 500, 1,200 people. So we take 1,200 divided by 15,000, the same labor force, multiplied by 100, and we get a natural rate of 8%. So the unemployment rate is 10%. The natural rate is 8%. What does that tell us? It tells us that with unemployment greater than the natural rate, we're operating under a recessionary gap. Okay, so that takes care of the first couple of questions. Next, we have to draw our Phillips curve. I've already got the axes here for you. Inflation on the y-axis, unemployment on the x. Now we have to show what we learned here, what we have calculated on a correctly labeled graph of the Phillips curve. Start with just the long run, short run Phillips curve. We have our vertical LRPC, downward sloping SRPC. Where they intersect, that would be the expected inflation rate. We know that. At the x-intercept of the LRPC, we put 8% because 8% represents the natural rate of unemployment in this case. We said there's a recessionary gap. We know there's a recessionary gap because unemployment is greater than natural rate. So what does that mean? It means that at this present time, the economy of country Z is operating to the right of LRPC with a higher unemployment rate of 10%. The inflation rate then we can conclude is less than expected. Don't be confused. Don't think of the gaps. Don't memorize the gaps from ADAS and try to apply them in the same way here. We have to understand Unemployment on the x-axis means we're going to look at things a little differently. Use the data, interpret the data, know that output is not on this model, but we can interpret the output gap as a result. Okay, nice work. Let's move on. Those are output gaps. What else can we do 3 different ways? Let's move on to another example. The second example, fiscal policy. At this stage, we're not going to go into great depth. We should know what fiscal policy is. We did that way back in Unit 3. Let's talk about fiscal policy and its application 3 different ways, how we can express what fiscal policy is and how it is applied in 3 different categories, 3 different ways. Words, numbers, pictures. Words first. What is fiscal policy? When and why is it used? Okay, good term for you to know and be able to use. Fiscal policy is a form of stabilization policy. We need to know who applies it. Obviously, it's the legislature. If you're talking about the United States, it's the Congress, with, of course, a lot of feedback, a lot of activity from the president as well. So there's Congress and the president of the United States. When is it applied? It's applied through counter-cyclical application. The way we're going to apply it in this course, at least in theory, is in the opposite direction of the business cycle. Now, in reality, it's not always counter-cyclical. There have been pro-cyclical policies that does happen from time to time. But in theory, we're going to talk about the application in a counter-cyclical direction. So when there's a recession, we typically are going to apply expansionary policy. In this course, we'll apply expansionary policy. If there's an inflationary gap, then there might be time for a contractionary policy. Tap the brakes a little bit, slow things down. Why is that? Fiscal policy, any stabilization policy, is applied to close output gaps, to align indicators with goals. When there are output gaps, economies are not operating at those predetermined targets, at those predetermined goals. So, stabilization policy, in this case, legislative policy, utilizing spending and taxes. Of course, transfers are included as part of spending. They're applied in a counter-cyclical direction. They're applied to close output gaps. All right, those are the words. Numbers. How and when do we interpret or apply fiscal policy using numbers? These are going to be multiplier questions. Let's do a brief little review of multiplier questions, because this is actually incredibly relevant. While the numbers themselves may be simplified, and they are, they're really not all that realistic. It does give us some insight into policy making and decisions that have to be made and factors that have to be considered when fiscal policies are actually determined and the amounts for fiscal policies are actually determined. So think about multipliers, think about the multiplier effect and how we use them. Here's an example. Given an MPC of 0.8 and a recessionary gap of $100 billion, calculate the minimum change in government spending required to close the gap. Okay, any question like this, you have to approach it from the angle of, all right, what information did they give me? And what are they asking me to do? What do I need to find? So in this case, they're asking you to close the gap using fiscal policy. You're only going to calculate government spending. You're not going to use taxes in this case because ceteris paribus, it didn't ask us to. I want you to always consider that the output gap, in this case, $100 billion output gap, represents a desired change in aggregate demand. That's a helpful way to look at this. It's not going to come out and say they want to increase output by this much. They're going to tell you, here's the recessionary gap. What you have to interpret then is how, using fiscal policy and the multiplier effect, how could policymakers go about closing that $100 billion gap? So the output gap itself represents a desired change in aggregate demand. That tells you one more piece of the puzzle in terms of what you're trying to do in this type of a question. So writing down what they've given me and what I need to do. The change in aggregate demand, the desired change in aggregate demand is $100 billion. MPC is 0.8, which tells me MPS is 0.2. With that data, I can say that my spending multiplier is going to be equal to 5. How do I use this data? What am I looking for? Well, I'm looking for the change in government spending. So ultimately what has happened here is I've been given 2 out of 3 pieces to a formula that I should know going into this exam. A potential or maximum change in aggregate demand is equal to the change in government spending times the spending multiplier. And if I have 2 of the 3, I can solve for the third one. This is basic algebra, solve for X. You've been doing this for a long, long time. So don't make it harder than it is. You have your data written down. Now plug that into your formula. $100 billion is going to equal to the change in government spending times 5. So essentially 5X equals 100. Solve for X, $20 billion. This is expressing fiscal policy in a numerical way. This is putting you in the position of policy advisor. And whoever it is, the senator, the president, whomever, they come to you and say, okay, we're going to put together a policy. We want to increase government spending to close a gap. How much should we increase it? You have to understand the multiplier effect in order to get to that $20 billion, which would be the answer to the question. Yes, this is a whole lot easier than real life, but that's okay because the policy, the lesson still applies. And that's the point. All right, so there it is by the numbers. How about the graph? Well, this is a very simple interpretation. How do we show expansionary fiscal policy? Well, assume that we do get that $20 billion increase in government spending, and that leads to the $100 billion increase in output, and we close the whole gap. We're going to show that with a rightward shift of aggregate demand, and with AD shifting to the right, price level goes up. We have some demand pull inflation. Output goes up and is now equal to full employment output. So once again, fiscal policy, words, numbers, pictures, all three. If we wanted to show contractionary, obviously we could do the same process going in the opposite direction. And that would occur typically when we're dealing with an inflationary gap. If we wanted to show the same thing on the Phillips curve, keeping in mind that we don't have output on this particular model, we could do that by showing that initially we're at point A, representing a recessionary gap, apply the fiscal policy, the expansionary fiscal policy. AD is going to shift to the right. Again, we can't show that here, but we can show movement along the SRPC, resulting with unemployment back at the natural rate, inflation back at the expected rate of inflation. Key lesson there, again, this is review from Unit 5. A shift of aggregate demand is going to move us along the SRPC. Had it been a shift of aggregate supply, then we would shift SRPC. But in this case, because it was a shift of aggregate demand, we're moving along the SRPC. All right, now let's do a little practice. Again, simulated FRQ, see what this might look like as a piece of an FRQ on the AP exam. Here's the question, I'll talk you through it. You'll pause your video, go ahead and answer it, and then we'll take a look at the answers. Current GDP of Pearlville is currently $75 billion below full employment. Identify whether the output gap is inflationary or recessionary. Draw a correctly labeled graph of an ADAS model representing Pearlville. Identify equilibrium price level and real output, full employment output. Given an MPC of 0.75, calculate the minimum change in taxes necessary to close the output gap. Illustrate on your graph from part A the effect of the change in taxes. So pause your video, answer the question, come back and we'll go over the answers. Okay, so starting at part A. All we have to do here is read and interpret. You didn't even have data to work through. You're just told output is currently $75 billion below full employment. This is a definitional question, should be straightforward, should be simple. We are dealing with a recessionary gap. All right. Moving on to part B. Draw a correctly labeled graph of an ADAS model representing Pearlville. Identify equilibrium price level and output. Identify full employment output. Again, keeping in mind that we have a recessionary gap, we should be showing this. We have price level on the y-axis, real GDP on the x, upward sloping SRAS, downward sloping AD, and of course LRAS is to the right of our short run equilibrium because we have a recessionary gap. Our current output level y is less than full employment. Make sure everything is labeled. Make sure everything is clear so you can get full credit for what you know. All right, that's part B. Part C, given an MPC of 0.75, calculate the minimum change in taxes necessary to close the output gap. So once again, our desired change in AD is going to be $75 billion. We want AD to increase by $75 billion to close that gap. We can't change taxes by 75 billion to get a change of 75 billion because we know there's a multiplier effect. Our tax multiplier in this case is going to be -3. Why? Tax multiplier is negative MPC over MPS. Negative 0.75 over 0.25 equals -3. We want to determine the change in taxes. So once again, I have 2 of the 3 pieces. All I have to do is plug those into the formula. A $75 billion change in aggregate demand is a result of the change in taxes times -3. We want to decrease taxes by $25 billion, cut taxes by $25 billion. So a $25 billion tax cut would result in a maximum change of $75 billion in aggregate demand, closing the gap. All right, then take that information, apply it to your graph for the final part of the question. AD is going to shift to the right, and as AD shifts to the right, price level goes up. Once again, we have demand pull inflation, output goes up. And if you were asked, you could conclude unemployment also goes down. Okay, there's your simulated question on fiscal policy. Moving on. Let's look at one more example. So we've done output gaps, we've done fiscal policy. Now let's go a little further. Let's open up the economy. Let's think about international trade. Why do nations trade? We should be able to answer why nations trade verbally, numerically, and graphically. 3 different ways. Verbally, we're going to use comparative advantage. We're going to explain why nations trade, how they gain from trade using comparative advantage. Then numerically, we're going to actually calculate opportunity cost to prove comparative advantage, and then use that data to prove gains from trade. And then visually show that on a nation's PPC, show how a nation can gain from comparative advantage in trade, from specialization in trade on the PPC, showing that consumption can actually exceed their maximum levels of production and sustainably do so. All right, so start with the words. Do we understand comparative advantage, the theory of comparative advantage? We first learned this all the way back in Unit 1. Now we're going to look at it from a broader perspective. Among 2 producers of a good, and in macroeconomics, we're typically talking about 2 nations as producers. They don't have to be, but we're talking about 2 nations being producers. Comparative advantage will be held by that producer which produces the good at the lower opportunity cost. So all other things held equal, whomever can produce at a lower opportunity cost has comparative advantage. The reason for that, remember again, terminology. What is opportunity cost? It's the highest valued foregone alternative to any decision made. In this case, in this context, a production question, we're saying what could have been produced. The producer that's giving up less is obviously has comparative advantage, but it implies that they are better equipped at producing that particular good because they're giving up less of the other good. This goes all the way back to Adam Smith, all the way back to Wealth of Nations, and not the theory, but the reality that geographically, resource-wise, not all countries are the same. They have different resources. They have different capabilities. This calculation of opportunity cost is evidence of that. And the theory of comparative advantage is based solely on that some producers, and they could be nations, are more equipped to produce some goods than others. And by adhering to that, adhering to comparative advantage, specializing, producing, and trading based upon it, total output will be greater, leading to mutually beneficial gains from trade. That's the theory that we're talking about here at its most basic level. So again, we have to be able to verbalize that. We want to be able to verbalize that. In some ways, it might be easier to express that just using the numbers. So knowing what we know about comparative advantage, we want to determine comparative advantage and gains from trade from a given set of data. Now, I'm not going to go into as much detail as I'm sure your teacher did back in Unit 1 when you first learned this, but I want to go back through it somewhat quickly. Let's say we have a set of data. Here we have 2 countries, generic, country X and country Y, generic goods, good A and good B. And we're given some data about the production of a fixed amount of good A and good B. In other words, this is telling us it takes 10 hours in country X to produce a unit of good A, takes 5 hours to produce good B, and country Y takes 10 hours to produce good A and 2 hours to produce a unit of good B. The process we want to work through is going to start with calculating opportunity costs and going from there. And the first thing we have to do is define the data. Pause, take 10 seconds, and define for yourself what kind of data you have been given. Does the data in this table, and this is pretty common how it's presented, does the data in the table represent inputs to production or outputs from production. Remember, inputs go in, outputs come out. In this particular case, you're told the amount of time it takes to produce a fixed amount of good A or good B. That's an input problem. Anytime you see time given, that's a dead giveaway that we're dealing with an input problem. So in this case, 10 hours to produce good A, 5 hours to produce good B, all in country X, input problem. Simple as it gets. All right. Now we need to calculate and interpret opportunity costs. So from this given data, we need to determine when country X, for example, produces a unit of good A, how much of good B could they have produced? What are they giving up in terms of good B when they choose to produce a unit of good A? I'm using an input problem here because I find those a little easier the first time through in order to better understand opportunity cost. Not only how we calculate it, but really what it means. Anybody can memorize a formula and how to calculate it, but what does it really mean? I think it's helpful. I have found it to be helpful to think of opportunity costs as exchange rates. What is one good worth in terms of the other good? Much like you think of exchange rates when you're doing the foreign exchange market. In that situation, you're saying, what is one currency worth in terms of another currency? Well, here you're saying, what is good A worth in terms of good B? When it's presented this way in terms of the amount of time to produce one, it becomes a whole lot easier. In this example, it takes 10 hours, obviously, to produce good A in country X. It takes 5 hours to produce good B. In those 10 hours, country X could have produced 2 units of good B because it only takes 5 hours to produce good B. For good B, it's going to be the reciprocal. The opportunity cost is going to be the reciprocal. In those 5 hours, good B could have produced half a unit of good A. Now you'll notice I'm putting these in the table. If you have pen and paper and you have a table like this, or even if you just write your own table based on a narrative, I think it's really helpful to put your opportunity cost in the table. So you're looking at all the data you need in one place at one time, and that's going to help you make those interpretations in the end. For country Y, we do the same thing. In 10 hours, they could have produced 5 units of good B. In 2 hours, they could have produced a fifth of a unit of good A. Okay. Now that we have those opportunity costs, we can actually make our interpretation, make our conclusion as far as comparative advantage is concerned. And as you can see, with the lower opportunity cost, country X is going to have comparative advantage in production of good A, which means they specialize in good A. Country Y is going to have comparative advantage in the production of good B. 1/5 is less than 1/2. Finally, we want to be able to determine a range of mutually beneficial terms of trade. Again, if you're just doing this freehand on your own without any type of guidance or prompt, pick the whole numbers and find an opportunity cost, find a number, I'm sorry, not an opportunity cost, a number that falls between those two numbers, and you're going to find mutually beneficial terms of trade. What I mean by that, look at good A. The opportunity cost in country X for good A was 2 units of B. In country Y, it was 5 units of B. So that's saying that in country X, to produce 1 unit of good A means to give up 2 units of good B. That's an exchange rate internally in country X. If I want to produce 1 more of these, I have to give up 2 of those. For country Y, they're going to be producing good B. If they want to produce 1 unit of good A, they have to give up 5 units of good B. So any number between those two is going to be mutually beneficial. So just pick one. 1 unit of good A for 3 units of good B. That's a mutually beneficial term of trade. Now, it doesn't have to be 3. It could be 2.5. It could be 3.54. You get the point. But the reason that's beneficial, again, back up to the concept of exchange rates. If country X on their own wanted to acquire another unit of good A, they have to give up 2 units of B. Or if they gave up a unit of good A, they would only acquire 2 units of good B. But through trade, in these terms of trade, they can give up a unit of good A and acquire 3 units of good B, something they're not capable of doing on their own. That's what makes it beneficial. From country Y's perspective, to acquire a unit of good A, they have to give up 5 units of good B on their own, but through trade, they only have to give up 3. So again, they're better off as a result. This concept of exchange rates, thinking of opportunity costs like an exchange rate, can really help you conceptualize terms of trade and make sense of them moving forward. All right, so we've done the words, we've done the numbers. Now let's look at pictures. How, when, and where do we show the gains from trade on a graph? The only graph we really have that can demonstrate this is going to be our PPC. What's difficult, however, is that the PPC shows production. It shows output. It doesn't show those gains in terms of consumption. So what we would have to do is, using a PPC, a generic PPC like this, if we wanted to illustrate that gains from trade existed, we would simply have to show that a nation benefited by being able to consume beyond their production possibilities. It's not that necessarily that they're producing, they are consuming beyond their production possibilities. We'll come back to that in just a moment. So all that said, let's practice. Let's do another simulated FRQ and see how we do with it in terms of applying international trade and expressing international trade 3 different ways. So here's your question. Let's talk through it, and then you can pause and give it some practice. Assume 2 nations, Weissville and Heartland, are considering a trade relationship based on comparative advantage considerations. The table below indicates the number of tacos and hot dogs each nation can produce in one day. Determine which nation will specialize in the production of each item. The nations settle on trading 1 taco for 4 hot dogs. Without specialization in trade, Heartland is capable of producing 100 tacos and 300 hot dogs. Calculate the gains from trade realized by Heartland, assuming they import 300 hot dogs. So they want to maintain that level of 300 hot dogs. Who wouldn't, right? Illustrate the gains from trade realized by Heartland on a correctly labeled graph of a PPC. Okay, so pause the video and then come back and we will go over the answers. Okay, part A. You're given this data. Before you can make any determinations, before you even read the data, you've got to consider what kind of data was I given. Well, here, as the prompt says, the table below indicates the number of tacos and hot dogs each nation can produce in one day. That's an output problem. That's output data. You're not given input this time, you're given output. What is the result of production? The result of the production process. And in reality, when you're given that, you're really given the 2 ends of a PPC. So if they were to specialize in tacos, how much they would make, specialize in hot dogs, how much they would make. And from there, we can calculate opportunity cost. Now, here's something I want you to consider. We get 3 hot dogs. That you should have got 3 hot dogs for tacos. The Heartland opportunity cost for producing 1 taco is going to be 3 hot dogs. But how did we get that? You can simply memorize that when it's an output problem. In this case, I would do hot dogs divided by tacos, 600 divided by 200, I would get 3 hot dogs. But look at it like a ratio. Look at it like an exchange rate. I want you just to consider for just a moment how this works, why that formula works. The 2 ends of the PPC are 200 and 600, right? So that's an exchange rate. They can do 200 or 600. Well, I want to reduce that 200 down to 1 because that's how I calculate opportunity cost. What is the cost of producing 1 more taco? To do that, look over here on my equation. To reduce 200 down to 1, I do 200 divided by 200. Well, in the case of a ratio, I have to divide both sides by the same thing, which means I also have to divide 600 by 200. Go to the next step. 1 taco is going to be worth 3 hot dogs based upon that basic equation. That's why you're memorizing 600 over 200 to find the opportunity cost of tacos in Heartland. Of course, when we move over to hot dogs, it's the reciprocal. So it becomes 200 over 600 or 1/3. So the opportunity cost of 1 hot dog is going to be 1/3 of a taco. And in Weissville, we do the same thing. The opportunity cost of a taco is going to be 6 hot dogs. And the opportunity cost of a hot dog is going to be 1/6 of a taco. Determine which nation will specialize in the production of each item. Well, that's based upon comparative advantage. So I'm simply looking for the lower opportunity cost. When it comes to tacos, it's going to be Heartland. 3 is less than 6. When it comes to hot dogs, it's Weissville. 1/6 is less than 1/3. Okay, so with that in mind, move on to part B. Nations settle on trading 1 taco for 4 hot dogs. Go back. Is that a mutually beneficial term of trade? Yes, it is. It falls between those opportunity costs for tacos. Nations settle on trading 1 taco for 4 hot dogs without specialization in trade. Heartland is capable of producing 100 tacos and 300 hot dogs. Calculate the gains from trade realized by Heartland, assuming they import 300 hot dogs. They want to end up with 300 hot dogs just like they started when they were operating on their own. So I'm big on tables. I'm big on organization. I'm going to organize my data like this. Our terms of trade were 1 to 4, 1 taco for 4 hot dogs. Prior to specialization in trade, we were told Heartland could produce 100 tacos, 300 hot dogs. That's a point on their PPC. It's right in the middle, actually. If they specialize, because they have comparative advantage in production of tacos, they're going to produce 200 tacos and 0 hot dogs. They want to have 300 hot dogs. In order to acquire those 300 hot dogs, what do they have to do? They have to give up some tacos. With terms of trade being 1 to 4, they're going to have to give up 75 tacos in order to acquire 300 hot dogs. Again, we're just applying the ratio here, applying that exchange rate, the terms of trade of 1 to 4. When they do that, after specialization in trade, they're going to wind up with 125 tacos and 300 hot dogs, the same 300 tacos they had on their own. So ultimately, what are their gains from trade? They gained an additional 25 tacos. That's the kind of question we're talking about. And that's, again, using numbers, using the data to express how nations can gain from specialization in trade based upon comparative advantage considerations. The last little piece of that, how do I show that on a PPC? Well, here is Heartland. You can see the two ends of the PPC, 200 and 600. You can see that on their own, they were producing 100 tacos and 300 hot dogs. When they specialize, they're on the y-intercept of 200 tacos and 0 hot dogs. When they specialize in trade, they're actually able to consume 125 tacos and 300 hot dogs. They are consuming beyond their production possibilities. All right, so what should we take away from all this? Ultimately, what I hope you take away is the ability to connect concepts in different ways, to express and connect concepts in multiple ways. So we did that 3 different ways. We did that with 3 different concepts: output gaps, fiscal policy, and international trade. And we did that by looking at how they're expressed in words, in numbers, and in pictures. Review that, keep that in mind. It doesn't only apply to these 3, it applies throughout the AP Macro curriculum, but use that approach to help you make those connections as you're reviewing and as you're applying your concepts, both on the exam and I would argue more importantly, well beyond. When you're watching the news, when you're keeping up with current events and you want to understand what's happening, know that we can express these concepts 3 different ways. I want to thank you for watching. I want to thank you for hanging in there. I want to thank you for all the work that you're doing to get ready for this AP Macro exam. And I would encourage you to stick around for the final video in this series. And I wish you the best of luck. Thanks a lot.